Good morning, Wale. Hi, everyone. My name is Yomi Oshamili. And first, before we continue or before we start anything, I would like to apologize to everyone that this event is starting later than we planned. It was due to issues we could not out beyond our control. Every, every everyone from forLoop apologizes for this, and now that we've gotten that out of the way, we'll go ahead with the event for today. Wale, good morning.
Hi, Yomi.
Yeah, hi everyone. This is Oyewale Oyediran. He's a software engineer at Konga. And do you want to introduce yourself, Wale?
Yeah, okay. My name is Oyewale Oyediran. I'm a software engineer at Konga, and I work on the enterprise team at Konga. So most of what we do powers the warehouse, build internal flows that ensure that the orders get delivered as fast as possible. And I write Java, PHP, Python, anything that has to write, that sort of things. Yeah.
Yeah, Wale is a great guy. We worked together back in Konga before I left Nigeria, and yeah, like would write one of the best codes I've seen out there. And I'm so glad that he will be sharing with us his experience on continuous integration, continuous deployment. And this is the first of a two-part series that we'll be talking about what continuous integration is, what continuous deployment is, and for people that have been hearing this time, try to essentially break down what it is and give people a head start on how they can get on the wagon. I hope I said that right. And this first part series would feature, of course, Wale is already here, and Wale will be talking about continuous integration in agile teams, best practices. The second iteration of this event will be on the 19th of November, where Mofesola Babalola from Venture Garden Group will be talking about how we can build a deployment pipeline, talking about tools, processes, and best practices. So during that period, we'll be going more into details and hands-on, and he would be showing us some demo and talking about the things he uses and what alternatives people can use. Same day, Ikem Okonkwo from Andela will be sharing his experience with us about how he works with microservice delivery pipelines, how they're able to integrate together different microservices and ensure consistent deployments and deploying things to life. That being said, Wale, are you ready to get this started?
Yeah.
Okay, great. I'm going to mute myself for a while, and if anyone has any question, it would be really nice. So in the post sent out, we said we would experiment with people calling in. What we had in mind, because we checked around different tools. Also, if you have anything, if you have any recommendation or have anything to share, please do not hesitate to drop this on the YouTube link or the YouTube chats area. Feel free to comment. Feel free to let us know how you feel. Feel free to, if there's something, of course, and one thing again, forLoop is not us, everybody here. The goal of forLoop is to bring everyone together to share knowledge and to set a good ground for everybody to talk about what they're working on. So Wale is top notch, but if you feel there's something you need to give us feedback on whatever he says, or if you feel there's something you can add on, please feel free to drop it in the comments box, in the comment section of the YouTube channel. Yeah, so Wale, over to you.
Okay, thanks, Yomi.
Yeah.
Please confirm that you can see my slide.
Yeah, I absolutely can. Yeah.
Okay, cool. So the topic of the middle of the title is continuous integration in agile teams, best practices. So okay, I already introduced myself. What are you doing? And okay, just first, one of the most important things I always like to point out anytime I'm talking about agile is basically that um, you have to find what works for you. There's no hard and fast rule to anything in agile. It's really about finding what works best for your team and keep improving things gradually, progressively. So you guys get to that Zen stage, that master stage, and where everybody is working optimally and stuff. So that being said, um, yeah. So that brings me to the first part, what CI is really about. So CI generally is one of the core components of an agile sprint. CI is primarily focused about ensuring that there's always a clean build of everything you're working on at every point in time, and also as frequently as things change. So in real life scenarios, this is about as soon as anybody commits, um, you push your code to the repository, and depending on how your team works, it you run a certain build process depending on your product where you compile your code, you test your code, you run your code quality measurements and everything, and you generate the artifact or binaries or whatever it is. So it's also about keeping your code base healthy when you're working with a team. So an hypothetical team, say 3 engineers, 2 testers, 1 product manager. Okay, yeah, that's pretty much an ideal team around. And it's very important that there is a central line that tells everybody what stage they are at the moment. So everybody can focus on their task, be it writing code, testing, trying to see what's going on at every point in time. CI also helps give visibility into the status of your code base at every point in time. It also helps us keep our code base healthy, so because we can actually do things like keeping our code quality under certain above certain thresholds and not making sure that anytime somebody tries to reduce this quality, if a person can actually be altered and notified and hints on what to do. It's also about ensuring that at every point in time, every iteration of the code is complete and correct. So in terms of correctness, that's where your tests come in, ensuring that any code that makes it to, let's say, the master branch, for instance, the test must have passed, all tests must have passed, and is also complete. All parts of the application is there and can be deployed at any time. So you ask fast. So say a Java project, your jar, but if your CI ensures that there's always a stable jar, you can see visibility into what jar can be deployed at any point in time. So we're going to just see some of the, I'm going to just talk about some of the intricacies, some of the important aspects of CI in, uh, yeah, from my experience. So many of the things I'm going to talk about will be from my experience at Konga.com. So I've worked at Konga for over 2 years now, and we try as much as possible to use agile methodology. Our teams are constantly trying to improve our use of agile. So we're not there yet, so I have to point that out. I'm happy to learn from some of the experiences. I really actually want to see what other people are doing like as regards continuous integration. Yeah.
Hello,
So as I
Wally.
said,
Hello,
yeah,
Wally.
yeah,
So
yeah.
sorry to stop you there. Some people on the group can't hear you, so maybe you can speak louder, or I'm not sure
Uh,
what we can do to make things better.
okay. How am I going to? Let me see. No. Okay. This guy. I'm gonna try to. Okay. So am I loud enough now? Uh,
I just
am I loud?
asked. I just said one of the participants, Leye, actually mentioned this. But I just asked on the group chat if it's better.
Okay.
But yeah, I think you should continue. Okay, okay. Okay.
Okay, I think people think I'm loud enough now, right?
Okay, yeah, much better. So yeah, thanks.
Okay. Okay, thank you, guys. So, so as I said, continuous integration is a key part of agile things. So the very good things always need something to keep them in line, working in the same direction. Everybody's pushing to the main line, to the central repository. So the main aim really is about getting the best quality code that solves the particular problem you're trying to solve in the master branch. I guess that's really what everybody's trying to do. So the process of this, where you have like 5, 6, 7 people trying to work, it would, without a sort of harness, something to keep people together, it will be difficult to actually maintain the quality of whatever it is you're churning out, and also the correctness of it. So CI actually helps us keep the integrity of a system. So that is, so CI is really a fundamental component of agile. Yeah. So one of the most important things in agile is source control. So I really want to think. I don't think anybody should be talking too much about this in 2016. Everybody uses some form of source control to manage their code base. Um, Git. Okay, I think a few people still use.
Yeah,
Yeah.
we had, I think our second forLoop Hangout was actually on Git. So
Yeah.
yeah, so if anyone wants to check that video out, it's on our YouTube channel. The handle is forLoop Nigeria. So yeah, so I'm sure most of our audience are
Yeah.
inclined.
Yeah, so Git is central to that. As part of the source control thing, the source control part, one of the most important parts for a truly agile team is regular commits. Like it's not enough just to use Git, but it's also very important to commit code, to check in code very frequently. And okay, I think I probably should modify not just checking, because not just commit, because you need to push for something like this is distributed. You need to push your code to say your dev branch or something like that. So the big advantage of regular commit is that it reduces conflict. I'm sure we all hate that part. Like you you work on your code, you commit, and you try to send a pull request or you try to merge, and you see somebody else has actually like modified the same line of code and things like that, and you have conflict. So one of the best ways to reduce conflict is by checking in code very frequently. So it doesn't interrupt conflict interrupt the flow. You have to decide which you have to decide which of the flow is which of the change sets is really the most complete version. Um, that's really that's really interrupting. Everybody has to like break whatever it is they're doing, and they have to like come into with you physically and try to understand, okay, what is the which is the correct change set and stuff. So one can really reduce that by checking the code frequently, sending your pull request, sending committing fast, sending your pull request in as soon as you're done. So yeah, this is also one of the most fundamental parts of agile teams. So whatever it is, depending on your team, you probably have a few people, more than one at least, 2, 3 people working on stuff. You need a branching strategy to um, to keep your code in sync, to keep your main line very clean. You need a branching strategy. Depending on what you're doing, your release flow and everything. So I think the most common strategy around is having the simplest is basically having a dev branch or something like that. Some people call it staging branch, anything, dev branch and a master branch. Yeah, so that's like the basic. So the master could be just something that what gets deployed to production, and then everybody checks in code into dev, and they do their test and everything. When they are ready to deploy to production, they merge to master and some of these things. That's the basic one. That's fine. Depending on what you're doing, that can be good enough. But as you grow, depending on the size of your team, it may actually be more difficult to actually go with a two branch strategy. Uh, so you might need, so at Konga, one of the things we also have is that we use feature branches actively. So whatever story, ticket, anything you call it that you're working on, is the branch name is defined by what you're working on. So it could be feature slash um, new checkout or something like that, depending on if the feature is checkout. So something like that, or it could be the story number if you're using some task managing tool like Jira, anything. So the main thing is that each feature have their own branch. Then anybody that is working on that feature checks into that branch. Then this branch can be tested. So when you are ready, if you have quality assurance people, they actually test this feature branch on their own. So that's where they want to test. So it's an isolated way of testing the new change set you are actually proposing. Then when it's passed, you can merge that into your dev branch where it undergoes testing with the entire code base. On the right hand side of the screen is one of the interesting Git branching model that's sort of popular among companies where they not only have feature branches, they also have things like release branches, hot fixes, say something breaks on production, you really need to fix it. You can't have time to go through the normal feature branching, quality assurance and stuff. You just quickly branch from master, fix it, merge it back to master, deploy. Then you can now like sync it back to your dev branch and all these things. So I always try to emphasize this every time. As with everything agile, you have to find what works for the team. You can't just break the team's flow and say, okay, guys, we have to do this. You have to start gradually, then improve, iterate some of these things, try out new things, and keep improving. That's really very, very fundamental to agile. So I'll be happy to answer questions. If there are any questions on some of these things, please interrupt me. I can't see the YouTube.
Sure, sure,
Why
sure.
TV.
Also, your presentation slide is not visible right now, so you might want to look into that.
The presentation slide is not visible.
Yeah,
Okay.
it's not visible. It's your face you've been seeing.
Sorry. I actually didn't know that. I didn't share my screen.
Yeah, okay. Yeah, I think it was when you went off for a minute to work on your
Yeah.
microphone.
So I'm sharing my screen now, right?
Okay, yeah, sure, go ahead.
Okay.
Okay, yeah, no,
So
yeah, it's good now.
yeah, so that's really that's really about branching strategy. So I'll be happy to know what sort of branching strategy people are using. So at Konga we use a lot of feature branches and hot fixes. So we have every feature has its own branch. When the feature is ready, you send the merge request, the pull request, and then your peers review the code, make comments, and keep and maybe iterate over it till everybody approves and is merged and it goes through the build process. We're going to see a lot about building next, and then the quality assurance engineers test these things and ensure that it meets the business requirements before this gets merged to master and deploy. So that's really how source control is actually central to continuous integration at Konga and from my personal experience too.
Yeah, I would like to add from my own experience, just so that like instead of me delaying like my comments or my contribution to the
Yeah.
end, I'll just like
Mm.
interject you every now and then. So
Okay.
I work at Shopify in Canada, and we have a team of over 800 engineers or thereabouts, and every single person, like just talking about the branching model, every single person has right access to the master branch. Essentially, you can literally make a commit and push like something to the master branch and fuck the entire system up. So the branching model we use is similar to what you are right there, but we threw away the staging or like the
Right.
stages you've seen in between having your feature branch and
Mm.
moving to production. And the goal there is to allow people to be able to move fast, because as you grow as a team, as a company, um, your development process becomes slower because there are lots of things you need to go through. So you don't want anybody being the roadblock to you getting your feature out there. So all we do is we also use the feature branching model, but the flavor is if you have something you need to work on, if there is a GitHub issue or a GitHub task or something you need to work on, you essentially create a branch off of master, and then you work on it and you make a pull request directly into production. So once you do that, then you're like you said, the source control bit is essential to continuous integration and things. So yeah, like once you make your pull request, yeah, the continuous integration things which you'll be talking about will take over from you creating your PR. And once that bit is done, it's merged directly into master. So yeah, I just decided to keep that into just to give an idea of how even larger organizations yeah, and do this kind of branching. Like it's no big deal. Even if you're just 3, it makes sense to also do like at least adopt some form of branching model that works for everyone. So yeah, that's all I have to add to what you just said.
Yeah, I quite agree with that. I really think as much as possible, all forms of testing should be automated as much as possible. That with that, when you have highly automated systems, you find out that you really don't need that staging or dev branch really most of the time. So we still do some form of manual. A lot of tests are automated at Konga, but there's still some form of manual test. So that's why usually when you have manual tests, you find yourself leading some form of intermediate branch between your feature branches and master. So yeah, so that brings me to the next part of the conversation, and that's really about the build tools. So one of the most important parts of continuous integration, okay, another most important part of continuous integration is really about building your source code. So we're going to talk about some of the components of building in a short while, but the summary of it is that a single command, the push of one button, running one single command on the terminal or something should be able to build, create a build of your software, of your repository or anything. And some of the tools that are central to this are build tools. Depending on what language your code base is, you probably have a different build tools. Build tool. My favorite is Gradle. I think maybe primarily because of my Java background or something. I just love Gradle. So there are quite others. There's Apache Ant. Ant is one of the most popular ones. So we use Ant actively at Konga. There's also CMake. So that's the make. It's probably like one of the oldest, the oldest I know and I've used. So it's primarily for Unix-based software, Unix-based tools. There's also Maven.
People still use CMake like for like new projects.
Yeah. Okay.
Really?
Yeah. Yeah. I think people do. People generally like see projects, Unix projects, not necessarily open source, but like tools that are built on the base of Unix. Many people still use Unix to build these things.
Oh, okay. I get what you mean.
Yeah. But these days I tend to favor Gradle and Ant. Say for Java projects, for instance, Gradle and Maven are the most popular. Gradle is sort of newer because I think it's based off Groovy. The Groovy language is very similar to. It allows you to write Java syntax as part of your build script, which is pretty interesting. Ant is it's a very powerful system. It's also based off Java, but you can use it for anything. So the PHP project on my team, we actually use Ant as our build to manage the process. I think I have an example of a build script later. I'll probably show. I'll show some of these things. But the most important thing is that one command, one tool, on the click of a button, on the typing of one command should create a build of whatever project, whatever software it is you're working on. And a build tool is central to that. Yeah, so some of the tasks that a build tool will do, the most important, okay, I don't know, I said this thing too much, the most important, everything is really important. So one of the tasks that a build tool should do is really about downloading dependencies. So depending on whatever project you're working on, I assume you're not building all the components from scratch. So you probably have some packages, some modules, some artifacts, and anything, any other external project, any external source code that you actually use as part of your project uh, already. So the build download part, the part of this, there has to be a part of your build tool that downloads this thing. So for PHP projects, I think Composer is probably like the most popular part. So as part of your build task would be about downloading dependencies. So that's where Composer install, Composer update comes down, where so you have it in your build file, say Ant for instance, is a part of your Ant file that run Composer update and it downloads all the dependencies that you have defined in your composer.json file. For Python projects, I think pip is very common. So you have your requirements.txt file where all your dependencies are defined. Then I think npm, the JavaScript ecosystem, use I think npm they use that and you download all that. So that's really about that part. So one command would perform this part too. The next part of
Sorry,
okay,
sorry.
yeah,
Yeah, based on the build tax, someone just suggested that
okay.
that that isn't the build tools dependent on the language. Yeah, it is totally dependent on the language and the tool set you are using. So if you're using PHP, you tend to use Composer. If you're using Python, you tend to use pip or easy. I think it's easy install for Python, right?
Yeah, pip for Python, pip for
Yeah,
Python.
yeah. I think like
Pip install.
yeah, Python guys used okay. Like I think like that's not why we're here.
Yeah,
um, then if you're using Node.js or JavaScript, you use npm. But interesting information. Like for people that don't know the Yarn project, Facebook recently released Yarn, and it's the new package. Like it's the most latest package manager if there is any. Um, JavaScript package manager, and it promises to do everything npm as everything npm does plus more. So like, and it was released by Facebook. So like, props to the Facebook guys. They've done so many things in the developer community recently, from React to GraphQL and now Yarn. And essentially, the primary problem that led to creation of Yarn was essentially dependency management. So for example, in Composer, when you install your Composer dependencies and you specify, say you want XYZ version, and like the projects you depend on, they depend on similar things you depend on. So for example, you depend on, say say you depend on Guzzle. You depend on XYZ version of Guzzle, but some projects that you depend on also depend on another version of Guzzle. When Composer is going to install your dependencies, it's going to install everything and maintain a file called the log file to actually specify which versions should be installed and the folder structure that should be used to install them, so that there is no conflict when you install your dependencies and I'm collaborating with you on your project and I install my dependencies. Because at the end of the day, we need some form of consistency in our dependency structure of the list of our dependencies, so there is no conflict between one version and the other. But with npm, by default, if you have a couple of dependencies, you install your dependencies, and then I'm collaborating with you on the project, there is a very high tendency that the order in which my dependencies are installed is different from the way yours is
yeah.
installed. So like npm tried to solve that using npm string wrap to essentially, but it wasn't enough. npm, because npm is a for profits organization, so they really don't give a shit about what's happening in the JavaScript world. Well, Facebook, as the bad guy that they are, released Yarn. that's the end of my story. Yeah. So if you guys want to check out Yan, it's it's a great tool. Literally, we've replaced npm with Yan in all our build tools at Shopify. Like immediately, like within the week, it was dropped. So if you want to do npm install, you just like type Yan and you install. So yeah, that's what I have to say.
But with the JavaScript, is it not like every day there's always something new or something like
Yeah.
there's always a new tool?
Yeah, absolutely. but yeah, that's the thing. But there would always be like those set of things that would actually win everybody's heart at the end of the day. And Yan is one of those things.
Yeah. Okay.
Yeah.
So yeah, thank you. I mean, so yeah, so that starts with the downloading dependencies part. The next part is about compiling your code. So as part of your build tool, this I think the compiling is probably the most important part. They are using a compiled language, for instance. So Java is like the most popular in this. Okay, let me not start language wars anyway. But so for example, Java. So I have a strong Java background. So forgive me if I diverge towards talking about Java and related technology. But that's that. So basically compiling your code, creating your compiled binaries, running say Java. So in PHP, there's really no compilation done interpreted. So this step may probably be missing in PHP projects, for instance. So so that's that. Then okay, yeah, this is the very important part. As part of your build process, your test should be run. All your tests should be run. So if you have unit tests, so it is at this part of your build phase where you'd have say PHP unit, you run your PHP unit binary on your project, or JUnit or PyUnit or any other thing you're working on. So it's important that if your project encounters a failing test, build should stop. I don't think anybody cares enough about information from a failing build. It's never going to be deployed anywhere. So it's important that the build is altered as soon as there are any failing tests. Is important. So we'll see more about that in later stages of this presentation. Yeah, so this is one of my favorite parts of my build process, and that's code quality. So when you work in an agile team, it's very important that you guys have a way of maintaining the health of your code. Like it's not just enough for people to deploy, to write features, write new features, get it merged and all. It's also important that you have to find a way to like keep the health of your project in check. Uh, so this can be in many forms. It could be about code coverage. You could, depending on what team you're working on, decide that okay, my project must have a 50% code coverage. So if you have that decision and say okay, our project must have 50% code coverage, someone checking code without test that sort of reduces the code coverage to say 49% or thereabouts, the build to fail. That's really how to use your CI process to actually help keep your code quality. So when it fails, the person sees the results and says, hey, why did this fail? And says, oh, okay, code coverage is below 50%. So things like that. So I'm not giving any rule. Some people have 30%. For some people, it may not just be about general code coverage. It could be about certain packages. Say maybe the business layer logic of the business logic part of the application to have 100% code coverage. Those rules. So here a tool. So there are many tools for depending on your language. For Java, there's Jacoco. So Jacoco is like one of the most popular even PHP projects use the Jacoco style for measuring code coverage and stuff like that. So it's really about measuring the percentage of the lines of code that are covered by unit tests. So that includes all the branches in your code and all that. So another code quality metric that you probably want to measure and allow use your CI process to help you manage is your coding standard. So whatever project you're working on, very agile teams always adopt a coding standard. So writing to a coding standard does not necessarily improve the performance of your code or anything, but it ensures that your code follows a certain guide, is uniform. When you have uniformity, it's easier for people to contribute because they're not trying to struggle with why is this code looking like this, why are my braces on a new line, and some of these things. So different languages have various coding standards. I think PHP, the PSR2 is probably like the most common, most adopted coding standard. Python, PEP, 8 standard. So depends. Your team has to decide which one you guys want to use and integrate this part into your CI process so that anybody that tries to check in code that violates this standard, the build process get off, the build is training, and the person has to like improve his code and all these things. So also LinkedIn, you want to, so LinkedIn is not necessarily a measurement, but is a code quality check to check that your code follows certain guidelines. You use threading properly, some of all these other things. If you don't want certain amounts of thread open, you can actually sniff deep into your code with certain tools to ensure that anybody that's checking new code into the repository does not violate these standards. Some other metrics that people measure, they're not necessarily central, but people measure these things. Copy paste detector, copy paste detection rather. So it's really about finding repetitions inside your code base, such that we really don't want to encourage people repeating things. So if you are having to repeat the same line of code, the same block of code more than 2-3 times, it might be very important for you to modularize this, then maybe put it in a function, then rather call the function, things like that. So that's really that. Then cyclomatic complexity, it's just a general measurement of the complexity of your code, all the branches, your ifs, your else, and try to see how complex your code is. You really don't want your code to be complex. Simplicity is very key in this profession. Yeah, it's a profession actually. So as I said, it's important that any change that violates any of your metrics does not get checked in. That's the way people use. That's the way we use continuous integration to maintain an acceptable standard of our code. So that way it keeps our project healthy. Do you have anything to add to this? Oh, okay. Yep. I hope I'm still live, guys. Okay. So next part is the package part. So this is another important part of continuous integration. It's about ensuring that oh, okay. So the package part is really about oh, okay. I got some duplication in my slide. Sorry about that. So it's about generating your build binaries, your artifacts, and all these things. So as part of your build process, there has to be a part that generates a sort of archive that says, okay, this was tested, it's passed, and this is exactly the source code that gets passed. So that's passed. So the easiest way is really about, depending on your project, it could be tagging the build, say this is build 1.40, and so it tags because it's stable, it's passed all your tests, it's gone through all your code quality measurements, you could tag it. It could be about generating your jars, your wars, your deb file, your zip file, and all these things. Also, another important part of this.
Sorry,
is,
quick question. How does the Git tagging work? Like during the build process, it's auto tagged.
So you can choose to auto tag your build. So it's really about, so if you have like a system user, the system user that and has say key in the build system, so he has access to your repository to do some particular operation. So if you have version numbering on your as part of your build system, you could tag the build so incrementally in the order in which people are checking the code. So I think the tagging part works. I've seen it being, we don't use it at Konga on a commit by commit basis, but I think we use it only for releases, the tag releases. So, but for open source projects whereby many people are working at the same time, I mean, it could be somebody else trying to merge, and so as soon as someone merges the master branch or something, the build process runs on the master branch, and that change set, that particular commit hash gets tagged as part of the build process. So that's really about how it could be discharged. So if you have a PHP project, for instance, I don't know what artifacts PHP projects, they don't really generate any special artifacts like say Java that generates jar files and all this. So it could just be about tagging that particular commit and say, okay, it could be the date. You could tag it with the date and timestamp at which it was. So just something to identify that this, so that in your CI server, you can just have, it can be a reference to that particular commit that this build 172 is linked to tag 143 on GitHub or something like that. So that's really about the tagging part.
All right, thanks.
Yeah. So another important artifact that your build process should generate for you is quality information. So it's not just enough for your code to measure quality. There should be visibility into some of these things. So you could have a dashboard depending on how rich your team is. I think your meat company, they're very rich here, Shopify. They just raise money anyhow. So, so you can afford some very big build displays where so you can see some graph that just shows the health of your repository. It could just be listing the status of the build at any point in time or something. So this is also a build artifact that is generated. It could just be an HTML display of the health of the application generally. So that is also, so many of all these tools generate these things for us. I think we have, I think I'll show you, there's an example of the build script in the next slide. I'll show you where you could generate many artifacts depending on whatever project you're building. Okay, yeah, here we are. So this is the link to one of the automation, the build script, a PHP build script. So this is the template that we use in my team at Konga. So if you look at the page very well, you just see some of the so this is an Ant build script. So some of the things that we measure in this thing is dependency. This pdepend is a PHP library that helps you measure cyclic dependencies in your code. PHP CPD, that's for copy paste detector. So many of these libraries are part of our Composer, our dev dependencies in Composer. So when we run builds and we download these dependencies and we run them against our test. So again, I'm going to show some. Okay, so this is the linting part. So Ant uses targets to just define different operations in our build file. So this guy just basically says that execute PHP on this directory, on the source directory. So it does linting, just checks the syntax and all these things to ensure that nobody checks in bad code where it's not even, it can't even be interpreted properly. PHP is not a compiled project, so you will not even know until someone has a syntax error in his code. Without something like this, you don't even know there's a syntax error. Well, if you're not covered by test, you don't even know there's a syntax error, and this gets pushed into the repository. So with a proper build tool and with a line like with a build script like this in your build file, it ensures that only code that has passed the linting gets committed to the repository.
And to add something to that linting, And it is important for everybody to understand that these principles that you are sharing with us on continuous integration in agile teams, it is entirely applicable to even when you are working as an individual. Because if you're working and you're on a project, you don't want to worry about if things have gone wrong. Write your test. Your CI tool would whatever CI tool or build tool that you're using will take care of letting you know. Because you might write your test, push, create a pull request, and forget to actually run your test locally. Because by the time you push, then your CI tool would pick it up and test. Also, you talked about LinkedIn. LinkedIn is very essential. It's very important in teams because we have different people collaborating. Like it's a very important part. That's why I decided to like chip in a bit.
Yeah, it is.
You have a lot of people with different mentality, with different perceptions, or what's the right word now? Sentiment, perspective. Yes, they think. Some people think your curly brace should start on the same line with your function. Some people think you should start on the next line. You get what I'm saying? But in your organization or in your team, if you say this is the coding standards we are going to go with, you can have a linter that actually scans your code every time you want to match the mainstream, checks and make sure it actually follows the agreed rules. So, like I said, all these things are not specific to agile teams. As an individual developer or a tech person working on anything, there are things that you can pick and use personally there. Yeah.
Yeah, I agree with you. I mean, it's very, very important because even when you're working, if you think it's just you alone working on a project, you could expand tomorrow. You could get some funding, and you got to hire like 3 different people to work on the project with you. You don't want to make it a nightmare for the next person to jump into the project. It should be very easy. They should be able to vouch for the quality of whatever it is existing, whether you are the only one that's working on it or not. So it's very, very important to apply these things, even on small projects, really. Yeah, so some other things that this template check. I'll also the link is in the slide. You can check it out. So okay, yeah. So we actually use this actively at Konga. We look for coding standard violation. So okay, we had a new guy join our team, and like he just figured out that his build was always failing. Like, and I was like, what the hell is going on here, man? Like he was speaking for them. I was like, guy, calm down, man. Look at your code. So we used PSR2, and it was writing the Java style, but we had agreed that okay, this is how our code is going to be. Our curly break for our PHP project is going to start on a new line for a function, and some of these things. So, but with a tool like this, it ensures that even if someone decides to violate this thing, his code cannot get committed, can't get built, it doesn't get merged into any repository because the build is failing and things like that. So that's really about it for. So the link is there. It's part of things that we can look at afterwards or something. I'll be happy to answer any questions regarding this. Yeah. Okay. Yeah. This is the big part. That's your build server. So whatever. So now you have a build tool, and you can generate a build at any point in time. Now it's important that your build process is highly automated. It's automated. So you have many people working on this project. You want to make sure.
So sorry to cut you. Some people cannot see the slide, but what I'm not sure now is whether they cannot see it right now or maybe it's blurry. But I can. So I'm going to try to follow up on that. But
Okay.
do you have this slide posted anywhere, shared anywhere right now?
Okay, maybe I'll make it public and I'll send you the link.
Okay, maybe you can just put it on Dropbox or something, and then we can share the link with everyone. But okay, yeah, maybe we can share the link with everyone, and yeah. Oh yeah, you can just send it to me on Skype, and I'll take care of that while you're doing your talk.
Okay.
Oh, okay. Someone said it's blurry.
Okay,
Have you tried messing with your video quality, your YouTube video quality?
No.
No, I'm talking about
No.
the audience. The audience should please check
Okay.
the audience should please check the video quality, because it could be you could be streaming this this talk at say 480p or something. So please check your YouTube settings and make sure the quality is at the highest. Well, it also depends on your internet though. When your bandwidth finishes, it's not forLoop. Yeah. So yeah, please just send me the file via Skype, and I'll take care of that. Thanks.
Okay, I sent you on Skype already.
All right, great.
I sent you Skype.
Great. Thanks. You can carry.
Yeah. So really, the build server is basically a centralized, essential system, essential machine or cluster of machines, depending on depending on your team and how much money you guys can afford, really. So it's basically a central environment, machine, nodes, anything you call it, for building your code, for building your software. So so depending on your so okay, let's talk about what it does first. So it basically like ensures that every change step that is pushed, that is when your build runs, it runs in sort of a sandbox environment. So this sandbox environment is going to try to match it with your production environment as much as possible. So you're probably going to configure the build environment to match your production environment. So these days, many build servers have a way of integrating Docker or some virtualization technology to ensure that you can match your production environment in a sort of sandbox where each build is tested. So it's not enough that your code runs on your local host. You have to work in the same environment that you're going to deploy it. And these are some of the things that your build server tries to help you with. So with a small team, you probably could have one machine acting as your build server. But when you are working at the scale of, say, Facebook, you probably don't want to have one server because everybody's commit is going to be waiting and they just be angry and chilling. Yeah. So you could just be the master. Your your build server configuration could consist of one machine, one machine. If you're a small thing, it could be one master with multiple slaves, whereby each of these slave nodes can also run builds so that people's builds don't just queue. So so some of the most the common build servers that you see around are Jenkins. So Jenkins is open source, it's free, and I used to use Jenkins a lot. We started using Jenkins in Konga, but we migrated to Bamboo. Bamboo is also some other very powerful build server environment. There are also services. So Travis, Circle CI, you can call them CI as a service. So so they have their CI cluster, and you could just link your repository with them and configure on their system. So so Travis, I think Travis is free for public GitHub projects. Correct me if I'm wrong, but yeah. Then there's Circle CI. I think Bitbucket just tried to do something like that for small things that cannot afford Bamboo. So Atlassian, or is it Atlassian? I never know how to pronounce that.
Yeah, Atlassian. I call it Atlassian. Yeah.
Okay. So they are the owners of Bamboo. So Bamboo is not free; it's paid for.
In fact, so expensive.
It's very expensive. That many people cannot afford it. So they started Bitbucket pipelines. So that's for people that are using Bitbucket, and it's a mini kind of a CI platform, just like Travis and Stafford CI. I hope they don't put money on that thing because I actually use Bitbucket for some Bitbucket pipelines for some of my private repositories. So really, you could just anything to work for you. So Jenkins, you can install Jenkins on your machine, on maybe a server, on DigitalOcean, AWS, anything. You could just set up a Jenkins stack somewhere there, and it could just serve as a build server for your company. So if you're working somewhere and they don't have a build server and they're talking about the cost of Bamboo and some of these things, just tell them not to worry. One AWS instance, install Jenkins on it, and it can actually serve as a build server. The build server is very fundamental to agile things.
and reach out to Wale to set it up for you.
Okay. I don't like DevOps again. so that's the build server. So some of the benefits of using a build server that it allows to see, yeah, this is very, very vital. So when somebody has a failing build, it's important that that the person realizes it, because the people may forget to run their test, their build process on their machine before committing, and this code gets committed and pushed. So when you have a build server, it runs the build and the build fails. So your build server is probably connected to your Slack. It just sends the webhook, or someone sends a Slack message to your channel that, hey, this build is failing, this commit is failing, and someone has to resolve it. Or it could just be as simple as sending an email, or just anything to notify people. So that's one of the benefits of the build server. Another one is that it makes build information available. It So it makes it easy for anybody to see information about every build. We can see how healthy our code has been over time, the percentage of our failing builds. It helps us know what we should do better as a team. So these are some of the benefits of having a build server. People can see the test results. They can see the code coverage right from an HTTP interface, for instance. It also makes it easy for anybody to get the latest artifact of your project. So I want say, okay, what's the popular open source project now, for instance? Picasso. Picasso is a image rendering or whatever library in Android, and I want, okay, my some people that are running this version is failing. I want to debug the code. This version of our app uses Picasso 2.1. How do I get Picasso 2.1? I just go to the build server and I download this. So you can do that with Git, but sometimes you just want the jar, maybe the particular jar file that you use, so you can easily get that from the build server. So this can also apply internally. So you want to know, so it makes it easy to get various artifacts, old artifacts, new artifacts. Then, so it could just be about uploading it. It could be like you upload it to S3. And okay, so next, I think next for you, Mofe is going to talk about continuous deployment strategies and how you can build deployment pipelines, and we're going to see more about that. But the build server is really, really central to this process in your agile team. So that's that with the build server. I'm happy to.
Quick question,
yeah.
Wally. So this event is called Continuous Integration. Some people use the term continuous deployment, some people use the term continuous delivery. And I'm sure people would have questioned this, but I personally have questioned what the difference is between continuous integration, continuous delivery, or deployment. And like in my research, there are lots of perspectives on it. Some people say integration is literally just the testing process, making sure your code is tested in as you walk. Some people say continuous delivery slash deployment involves shipping your code to production. You know, some people say continuous delivery is the set of processes. I don't know, but I just wanted to know what your take is in those terms.
Yeah, so thank you, Yomi. So there's really a lot of overlap in many of these terms. The basic one really is continuous integration. It's really so continuous integration is mainly about the master branch, as far as I'm concerned. That's really the easiest way to describe it. It's not really about what is running in production or at every point in time. It's about the health of your master branch. So as soon as people are checking in branches, is running the test, it's passing and it's tagging, or it's creating the artifacts. It could be that upload the build to S3, the zip file to S3, and that's really the end of continuous integration. So deployment can take it a step further and saying that, okay, as soon as this branch is done, deploy it to my staging environment. As soon as anybody merge, as soon as the feature branch is, the build is passed, the tests are running, deploy it immediately to the staging environment automatically. So that's really about continuous deployment. So continuous delivery and deployment, they're nearly the same. It depends on it's just really terminology. So it could be some people are crazy enough, like their things are very extreme in the sense that this flow extends to their production environment. All their tests are automated. As soon as your feature branch is passed, it's merged automatically to master. As soon as there's a new merge to master, that is automatically deployed to production. So that's really an extreme. I think I tried to preach that at Konga, but quite a lot of people, some people were skeptical and like, hey, guy, calm down now. We need to like test this thing, like, of course. So that's really you have to your team has to move progressively. You guys can get to a stage whereby all of you are now like Jeff Dean kind of engineers, and all your codes are 100 over 100 at all points in time. And as soon as it gets matched to master, there's nothing really stopping this thing from getting into production immediately. And that way, people are seeing changes. Gradual changes are small, and as they're small and they're making impact immediately.
I see what you mean.
That's really it.
Right, I see what you mean. Okay, nice. Yeah, I was also going to add that so it's in my work on what we do in terms of deployment and integrating tests is so we use Circle CI to actually pick up the test, run the test, and create the build and push it to Amazon S3. And then to automate deployment, what we use is we run Ansible. We use Ansible for that. So what essentially, I think the reason why we do that is because the deployment process. So when we ship a new feature or code, it doesn't have to be available immediately. So the deployment process is separate from the integration and building phase. And you might choose to deploy on a subset of your servers. So the thing, what we do is we pretty much we write scrapers, and we have like I think like 40 servers that crawl the web. So if we want to deploy, what we do is we use Ansible, and what Ansible pretty much does is it goes to S3, it looks for the latest build of that project, pulls it down, and then extracts it and deploys it. You get what I mean? So if all you're looking for is just deployment, or you want to do basic thing like maybe you just want to git pull. So like a common practice is you're using source control. You're like, yay, I can now go on my server and do git pull to deploy. You don't have to always do that. You can go on ansible.com, write a simple Ansible script that automates that process, pulls, installs your dependencies, and ships your code. Yeah. So people can check out Ansible too. From what's their name again? I think they're also the ones behind Terraform and what's the other tool other than Docker and Vagrant. I think they're the guys behind Vagrant. Yeah. So you can check them out too. Yeah.
Thanks, Yomi. So that's really it about build server. So this is called staging environment. So it could be an important part for an agile team, just to test environment that matches your production environment. So this is a server environment that your build gets deployed to. So this is actually an extension of continuous integration. It's probably getting closer to continuous deployment or something, where as soon as all builds get deployed to a certain environment, and people can actually go and test that particular feature. So all successful builds to get deployed there, and people that need to do manual testing, if you need to do some manual checks before these things get deployed to production, it can happen in this environment. So just an extra level of integrity to your project. So that's really it.
Your slides stopped showing, by the way.
Yeah. Oh, okay. I keep forgetting this part. Sorry. Yeah. Yeah, so yeah, staging environment is just a test environment that matches your production systems as much as possible, and builds get deployed here. So it's an extension of continuous integration, but it's really a good part. I'm really looking forward to the next forLoop hangout, so that I really want to see how Mofe, I want to see some of his deployment pipelines, his deployment strategies, and how these things work. So you guys should tune in for that. So that's really it for me. So I just added a few references for further studies. You want to see some of the thoughts. So these are some of the thoughts I follow, some of the things that shape my thoughts around continuous integration. Yeah, so that's it. As very important with everything agile, it's important to find what works best for your team and progressively improve this thing. That's true agility. It's not just enough to like, okay, this is what Martin Fowler said, and okay, guys, everybody here, we're going to do this thing the Martin Fowler way. No, no, no. You can just take a bit of it, try it out. Does it work for us? Oh, okay, that thing is different. Let's do it this way. So you can always do things slightly different, but it's important to progressively improve. Yeah, thank you.
Interesting. Thanks a lot, Wally.
Yeah.
Yeah, this has really been interesting. Really interesting. Um, I'm thinking. I don't know if our audience has any question, but um, let me see. If you have any question, anyone out there, if you have any question, feel free to drop it in the chat or use the question and answer tool. Actually, the question and answer tool is not up right now, but feel free to drop a comment on the chat. Most times, yeah, agile is most times, yeah. Wale, everybody is clapping for you. Yeah, good job. It was really a great presentation. But I would like to see if anybody has any suggestion or addition or question. And in the meantime, I would like to use this opportunity to thank everybody that has facilitated this event, that has spread the news, or that has essentially spread the word and brought everybody here. And again, I sincerely apologize for starting this event very late. Sincerely apologize. Also, the follow-up event, the follow-up hangout, is in 2 weeks from now, and this is practically an introduction. There was no plan to go in depth into, say, pulling out code base or something, or like creating demos. The next one, we're going to be having 2 presentations, and like I said earlier, Mofe from Venture Garden Group will be talking about deployment pipeline, and will be introducing us to different tools. So you'll be seeing some of the things that Wale has talked about, the things like Circle CI. At Shopify, we actually use BuildKite. I didn't know what BuildKite was until I actually got there. Yeah, and Ikem from Andela will be talking about microservice delivery, and we had our first Google Hangout talking about microservice architectures, where Ezra Ulibi from Paystack actually talked about this. So yeah, next 2 weeks from now, November 19th, will be fun. This has been fun. It will be much more fun. And yeah, I look forward to everybody being on that, and we'll definitely not start late 2 weeks from now. So someone has a question. What crazy thing happened in your team that made everyone get on CI tree? Do you want to go on that? That's from Olaolu.
Yeah, I think I saw that question. So to be very honest, I'm not going to give some bullshit story and say, okay, we just add some crazy inspiration and like that. So I remember our director of our VP of engineering then,
What was that?
he just brought in June then, director of engineering.
June.
Yeah, it brought in an agile coach to just work with us for like a few weeks, maybe about a month or thereabout.
Yeah.
And so he was just working, sharing ideas with us. and we really liked the idea. And that was when we really started. We just took off with it. We started gradually. I think that was when we first installed Jenkins at Konga. We installed it, we ran our build process through it. I think myself and Abiola, we started it and everybody got on it, and it was really exciting. We had a build dashboard, and we could see, just being able to see the general progress of the team was really exciting to us then, and that was really the groundwork for it. And gradually, every other team liked the idea, and we started doing it. We moved to Bamboo to give us greater powers around it, and it was fun. It's exciting. We're able to deliver software faster, and we can sleep with two eyes closed, knowing that the probability that the bad code is going to make it to production is very much reduced. So it's a good one for us. That's how we started with the agile bandwagon.
Yeah, Adeyemi Ola, you just actually shared one experience which I can totally relate with. It was like the example you gave was that time someone forgot the character I, edited with Vim at the top of a PHP script in Magento and broke checkout. And like, this is so typical. I mean, like, you have two screens, you are working on two screens, and you get on your laptop, you log in, and you're like, you think your focus is on a particular application, but your focus is actually on the code editor, and you're like typing, and you realize, oh shit, okay, it's not the app, and then you switch your window, but you've already typed stuff in your code base that you don't know, and you mistakenly commit and push it. Hey, as in, like, it's a typical thing. Oh, and Yemi was like, this made Jim to be in the office till 12 midnight, and yeah, like, and one crucial thing to continuous integration that cannot be overlooked is testing. Testing is a whole new topic on its own. You have to test. You have to write your test. You have to, depending on the tool or the language you use, you need to make sure you understand the available testing libraries out there and make sure you write your test. It is important to write your test. I'm a living witness of not writing tests. So it is unfortunate to say this, but I built Principal while I was at Konga on a contract basis. So right now I manage Principal as the CTO. And back then, like, I give no shit about writing tests. And now that, like, it was pretty much a contract. Like, Yomi, the CEO, reached out to me through Ezra back then, and I built the thing. And in the last, to be honest with you, we still don't have like a good code coverage. And to be honest with you, it's 5 hours difference right here from here tonight, because I'm in Canada. And to be honest with you, several times in the past couple of weeks, I've been waking up at 4 a.m. that something bad happens. And why? Like, people I'm serious, people would be able to check out, people would be able to buy things. This is real situation. And why? Because we've written code that wasn't properly tested, and something has gone wrong, and nobody has any idea what happens. And the solution there, the solution will be to go on the server and try to start debugging or checking through the logs, you know. So yeah, testing is really important, and you really need to cultivate the habit of testing. Yeah. So yeah, someone has another question. What are your thoughts around building pull requests, and how does it improve the CI process? That's from Olaye.
Okay, I like that. So pull requests are so as I said with Agile, it's a gradual thing. You guys, you could just start with just a build server, then you decide that okay, merges should not be automated, and that there should be code reviews. I think code reviews are very important in not just improving the quality of code, but sharing knowledge across team members. So that's also one of the big benefits of code reviews. It ensures that everybody in the team knows what everybody is doing, and I can actually give my opinion into what you're doing, and we can actually ship better software, which is really the essence of what we're doing. So then building. So usually, so for instance, at Konga, we run our build process on feature branches. So when you push, so every feature branch that you have, to get built, the CI process get built, you can actually so it gets deployed to a sort of a feature branch environment where you can see this your changes you've made in the context of the entire system. Then when your PR, so you create a PR to say a dev branch and it is reviewed, as soon as it's reviewed, it gets merged. So once it's merged, it triggers another build, and so the dev branch is built, and you can see the dev branch environment. So at every stage of the CI process, a build always takes place to ensure that, because it's not, you need to measure, you need to look at the quality of what you are doing, also in the context of the big picture, in the context of what your other team members are doing. So the build should happen at every merge. So when you are, so the, if you have maybe a small server for your build system, you cannot afford too many build processes. At the very minimum, your primary branches, say the master and your staging branch, should trigger a build. So anytime someone merges to your dev branch, if you have one, or your master branch, it should trigger a build. So at Konga, we have our repositories usually have rules like, say, um, before a merge can be approved, there must be three uh, approvals, three code review approvals. Then there must be a successful build. So your feature branch must build successfully before we can merge. So Bamboo allows us to do some of these things. So if there is no successful build, the merge button is even going to be disabled. So you can't actually merge. So our Bamboo integrates with, we use Big Bucket Server, Stash, it was functionally called Stash internally. So they are integrated with each other such that as soon as, so if your project, if there's no successful build, you can, even if everybody approves, even if the CEO, the director of technology approves your pull request, if there's no successful build, it doesn't get merged. So that kind of rule helps us ensure that the build process is really, really integrated into the PR field.
Yeah, I totally agree, and it's exactly the same thing in my head. But I'll just add, the question he asked. I'm just going to read it again.
Okay.
It was like, what are your thoughts around building pull requests, and how does it improve the shared process? Like, from my own perspective, I see two things: the concept of pull request, and in relation to the CI process. I would answer that question from the back. The CI process, first and purpose. You already said CI process. I do not see CI as being a tool or a set of tools. I see it as a process, and in my opinion, it consists of everything you will do to make sure everything is fine, right? To make sure you are shipping quality code, to make sure your deployment process is on point. You get what I mean? And it's the pull request process, as far as I'm concerned, is part of the CI process. It's also part of, so the same way you write tests and your code is tested, people are actually looking at your code and looking out for you breaking things, or you paying people times two of what you should pay if you're working on a financial system. You get what I mean?
Yeah.
So
Yeah.
so that's the way I think essentially pull requests is part of the continuous integration process. That is my own perspective and answer. Also, another importance of pull request is I use the words boss factor. Now, according to Wikipedia, the boss factor is the minimum number of team members that have to suddenly disappear from a project before the project stalls due to lack of knowledge or competent personnel. So, like you said, knowledge sharing. So, boss factor is essentially, okay, if you are the only one working on the project and you suddenly disappear, does the project end at that point? Essentially, you want to increase your boss factor as much as possible, and you really need to use pull requests. So yeah, that's how I would approach that.
Yeah.
Do we have more questions? Nice on wheels.
Thanks, guys.
Yeah, so thanks a lot, everyone. Thanks a lot for watching. I would say watching. Thanks a lot for watching. Yeah, and hope to see you next time. Yeah, signing out. Drops mic. Wally.
Thanks, guys.
Yeah, cheers.
Yeah, cheers.